This presentation will consider the design features of the Osteo-Ti dental implant. The implant is available in a number of sizes and dimensions and has many useful features which will be covered in this presentation. The system combines the evidence-based, proven beneficial features of a taper lock implant abutment interface, platform switching with the restorative advantages of an internal hex. What are the main features of this system? Well, it consists of a selection of popular diameters and lengths. There's platform switching over the entire range, which helps minimize crestal bone loss. A standard hex size throughout the entire range means that insertion tools and abutments can be common to all implant sizes and are standard. All components have friction fit and hermetic seal, eliminating micro leakage and preserving crestal bone. The surface is an SLL type, which has been proven to enhance integration. The geometry of the implant body is tapered, which improves primary fixation. And finally, the implant is self-tapping and drilling, which reduces the number of drilling stages and ultimately improves primary fixation. The system therefore combines all the recognized evidence-based advantages in one modern system. So the system has platform switching. And as I said, this is incorporated throughout the entire range, including even the smallest diameter at 3.25. And perhaps this makes it unique amongst implant systems in that it is probably the only small diameter implant to have platform switching. If we look at the difference between standard implant abutment interfaces and a platform switched implant interface, as can be seen on the left hand side, we can see that the abutment is actually narrower than the implant platform, and this results in the horizontal placement of the biological width, so preserving your crestal bone. It also incorporates a hermetic seal, which not only improves the fit of the abutment to the implant, reducing the amount of possible loosening during function, but the seal also eliminates effectively micro leakage, which has been implicated again in crestal bone loss. As previously stated, the components actually lock together, and this drastically reduces the amount of component loosening and abutment loosening of the implant restoration in function. The threads are taken up high on the entire range except for the 3.25 where the head is grip blasted. A high thread helps preserve bone at the crestal level. If we look at the implant design features which promote primary fixation important for osseointegration, they are as follows. A high thread preserves crestal bone. Surface treatments, the SLL surface with proven enhanced integration. A self-expanding taper along the thread or the body of the implant expands bone on insertion, again improving primary fixation. The implant is self-drilling and tapping, and these are features which again improve primary fixation and also reduce the number of preparatory steps required to prepare the osteotomy site. The thread is designed for speedy insert, meaning that the pitch is such that the implant can be inserted with the minimum number of rotations. This reduces again the amount of damage to the bone implant interface caused through the insertion and improves again primary stability. All these features are accepted for improving primary stability and are incorporated into all implants in the range as standard. This is an evidence-based system for reliable treatment outcomes.